In this video, we're going to take a look at the second lecture about oligopoly, and this one's really all about game theory. Now, you could take an entire class in game theory. It's a branch of mathematics, that's actually kind of new. It really only developed in the 20th century, mathematics. And there's lots of interesting applications of game theory. So there's game theory applications in obviously economics, but there's game theory applications in science and in psychology. There's tons of different places where game theory starts to show up. So it's a neat thing, and there are lots of online classes actually that you could take and watch. For example, like MIT they put their game theory class online, and it's really cool. So I highly recommend kind of checking it out. It's just a neat branch of math. Now, we are not going to get super mathematical with it, but we are going to talk a little bit about some technical things. So there's some basic things to understand. The first is it's just the study of how interdependent agents make decisions. So it's when your decision affects my outcome, and we are interdependent. That's what that means. And our strategic decision means that we have some kind of reasoning for choosing what we're choosing to give us the best outcome. So what we're really examining are payoffs, and that's the fancy word for our outcomes for the various decisions that we make given someone else's decisions. So if you decide to advertise, what happens if I also choose to advertise? What will be my outcome? If you decide to not advertise and I decide to advertise, what would be the outcome? So that's what we're going to be looking at. Some terms that we need to probably understand. First is what's called a dominant strategy, and this one's super important. We have to know this one for the exam. This is the strategy or the choice, right, where that you make decisions that result in a better payoff for you than any other decision that you made, regardless of what the other person decides to do. So in other words, if you always choose to do something, no matter what the other person does, then that's a dominant strategy. So it's what you always choose, right? It's regardless. So always choose regardless. The second one is Pareto efficiency, and this is one where we'd say it's the best outcome for all the agents combined. Not necessarily the most common result, but it would be the best outcome for everybody combined. Then the third is Nash Equilibrium. This is another one that we absolutely need to know. And this is the one where no participant, so you or me, if it's a two-player game, is going to gain anything by changing the thing that they choose to do, by changing their choice, as long as the other players continue doing what they're doing. And we're going to be able to identify those in a second, but it's not the same as a dominant strategy, and it's not necessarily always the best outcome for both, the Pareto efficient outcome. So we're going to look at two problems here, and these are kind of work through two different problems, and the numbers in the payoff matrix are telling us here's how much the revenue that these schools get. So we have two schools, JBS and MICDS. And the way we read these is John Burroughs can decide to either maintain or John Burroughs can lower tuition. And MICDS can either maintain or lower. And the two choices don't really matter for us, like what they end up doing, but the choices will affect what the other one gets. The other thing that we need to know to be able to read these is that the first number, the left number, right, this left-hand number goes with the left-hand player. So the left-hand number goes with the left-hand player, okay? The right number goes with the right-hand player, the one over on the right. So, for example, if they both chose to maintain tuition rates at the current level, John Burroughs would get 26, and MICDS would get 54. So if they both lower here and lower here, then John Burroughs would get 24, or 22, excuse me. John Burroughs would get 22, JBS, and MICDS would get 48 if they both lowered. If John Burroughs maintained, so was in this row, and MICDS chose to lower, John Burroughs would get 16, MICDS would get 60. And if John Burroughs lowered and MICDS maintained, then John Burroughs would get 30 and MICDS would get 44. Now what we're going to do is we're going to circle what they would choose to do, and the way we do this is we play as one of the players. We just pick a player in our head and we say like, okay, let's play as John Burroughs. If John Burroughs thinks MICDS, yeah, they're going to maintain. We'll just assume for a second that they decide, MICDS decides to maintain. What should we do if we're John Burroughs? We could either get 26 by maintaining, or we could get 30 by lowering. Well, we're going to lower. We'd prefer 30 because 30 is bigger than 26. Now, on the other hand, what should we do as John Burroughs if MICDS lowers their tuition? Well, we could keep it the same, maintain, and get 16, or we could lower and get 22. Well, we're going to choose the bigger number because that's more money, 22. So no matter what, now we can kind of back out of this for a second and see, no matter what MICDS chooses to do, maintain or lower, we will always lower our tuition. So that's our dominant strategy, lower tuition. Now, we got to play as MICDS for a second. All right, so flip your head, pretend you're MICDS. We know if we're MICDS, we know this information as well, so we know John Burroughs is going to lower. We always know they're going to. So if we choose to maintain, we'll get 44. If we choose to lower, we'll get 48. Which one do we want? Well, do we want 44 or 48? If we're MICDS, we want 48. Now, for a second, just for a second, humor me. If John Burroughs messes up and decides to maintain, which we know they won't, we at MICDS could maintain and get 54, or we could lower and get 60. Which one we're going to do? Well, we're going to lower and get 60. So we know that MICDS also has a dominant strategy to lower, because no matter what, we're always going to stay in that column. Now, the numbers could be flipped around, right? We could have ended up finding that they always maintain. But either way. Now, this is the easy question, right? I know this seems to look weird, but they both will lower, right? So they both lower their tuition. And the easiest way to spot it is to go, well, what are they going to end up doing? Where is the two circles? Those two circles means that's a Nash equilibrium. The two circles in a box means it's a Nash. And if we look up here, no participant will gain by changing their choice as long as the others remain the same. So in other words, MICDS will never switch from lowering to maintaining and getting 44. There's no reason for them to switch because they'd switch from 48 to 44 so long as John Burroughs stays the same. Now likewise, John Burroughs will not switch and go from 22 to 16 by going from lower to maintain. There's no reason for them to do that so long as MICDS stays in the lowering. So John Burroughs is stuck here as 22. Now observe momentarily, what box is the best outcome for both of them? All right, I'll give you a second to kind of ponder that. If you added them both together, here's 74. If you added these both together, that's 80. If you add these both together, that's 70. If you add these both together, it's 76. So this one's actually one of the worst ones. It is the worst one for them to both lower. They both together get 70. This one's the best one. But they're not going to do that if this is a single time game. Now in the long run they might, and there's some tit for tat strategies and some things that your textbook talks about where they might actually end up with that maintain. But if it's a single iteration of a game, one shot deal, then they will both end up in the lower box. Let's try it again. Clifford Taxi versus AC/DC. So we're going to do this one a little bit quicker. If Clifford decides to maintain, what should AC/DC do? Should they get 150 by maintaining, or should they get 110 by lowering? Well, AC/DC will maintain. If Clifford, so I'm playing as AC/DC, if Clifford lowers, what should we do? 120 or 100? Well, 120 sounds better to me. So that means AC/DC will always maintain. Okay, so that's what AC/DC will do. What will Clifford do? Well, Clifford knows AC/DC is always going to maintain. Okay, so what should they do? Should they lower or maintain? Well, they would prefer 140 instead of 130, so they will maintain as well. Now, so we know that they'll maintain, and we know the Nash is maintain. Okay. But let's say for a moment, let's say AC/DC did decide to lower. What should Clifford do? If AC/DC chose to lower, Clifford could get 120 or 150. So they would choose that, actually. So we actually can observe that Clifford does not have a dominant strategy in this one. This one is an example where Clifford doesn't have a dominant strategy, but we still know that Clifford will maintain because that's what they know AC/DC is going to do. Now, the last tricky part, redraw the payoff matrix, showing a subsidy of $20 to firms that lower prices. Okay, firms that lower the prices. So we're going to redraw it, okay, just like this. Redraw. And we'll say this is the maintain, and that's the lower. This is the maintain and the lower. And this is Clifford. Okay, and this is AC/DC. So they get $20 if they choose to lower the tuition, okay? So, or the lower the price. So up here, if they choose lower, lower, both choose lower, lower, then both of them get an extra 20. So we add 20 to that 150, and we go 170. And we add 20 to that 100 right here. Now, if they both maintain, neither one of them gets the $20, right? Because they only get the $20 if they lower prices. So maintain 150 and 140 stay the same. Okay, stays the same. Now, here's where it gets a little trickier, just a little bit, but I believe in you. I think you can do this. If Clifford maintains and AC/DC lowers, only one of them is going to get the $20, and it's going to be the one that lowers, and that's the 110. Remember, the right-hand number goes with the right-hand player, so the 110 will become 130, because that's the one where they get the $20. But Clifford will not get it because Clifford is maintaining, so Clifford will still get their 120. Clifford will still get their 120. Now, that's a little tricky. We've got to do the process again for this box. If AC/DC maintains and Clifford lowers, well, that means Clifford is going to get the $20, so their 130 becomes 150. And AC/DC's 120 will stay the same. Now, let's go ahead and solve it. Let's make sure we know how to do it and see what changes. So if AC/DC chooses to maintain, what should we do as Clifford? Should we maintain or should we lower? 140 or 150? Oh, now we're going to lower because we'd prefer 150 to 140. If AC/DC decides to lower, and we don't know what they're going to do off the top of our head before Clifford, if they choose to lower, we could maintain and get 120, or we could lower and get 170. We're going to definitely lower. So now we have a dominant strategy to go lower. Right? Old Clifford will always go lower. Now, let's say if we know that Clifford's going to go lower, what should AC/DC do? Should it maintain or should it go lower and get the extra money? Oh, wait. I think I made a mistake here. This 100 should be 120. Ooh, brain fart. Oh, no. So that's 120. Okay. Now, this one, they're ambivalent. They're ambivalent to this. Now, on a test question, you're not going to get an ambivalence point like this. Okay, you're not going to get an ambivalence point. But we can basically say either one, that they basically flip a dice and they say either one would be fine. Okay, they flip a coin and they say either one's fine. Now, we know that maintain, right? We know that Clifford's not going to maintain, but what would AC/DC do if they decided to do that? Well, they could get 150 or 130. They'd choose here that. So we wouldn't say that AC/DC, we wouldn't say they have a dominant strategy, because although, yes, they may at times always maintain, this is a random choice between these two. And we can find, though, that the Nash equilibrium is no longer maintain. You have a Nash, and it's a choice here where, depending on the coin flip, of either maintain and lower and lower. So again, on a test, you're not going to get that ambivalence point like that. They'll just say instead it's like $25 or something like that. And then that would set basically this one up to be 125, this one that I'm pointing to. But in general, it's not that hard either. So hopefully this helps you understand, like I said initially, the Nash equilibrium. That's where you have two circles in a box. Okay, and the dominant strategy is what you always choose if that's true. But we know that, like, for example, sometimes you won't have a dominant strategy. Like in this example, Clifford does not have a dominant strategy because sometimes they maintain and they get 140. Sometimes they'll lower and choose 150. So hopefully this helps you understand game theory. We're going to do a lot more practice with it when I return, and I'll see you next time. Bye-bye.